The aim of the simulation is to apply the continuity and Bernoulli equations to the motion of fluids. The simulation shows part of a cylindrical fluid vein and three rheumatic lines. In the help section, the analytical theory of the simulation is referenced. The parameter x1 indicates the horizontal position of the initial cross-section A1. The parameter y1 denotes the vertical position of the cross-section A1. The parameter A1 represents the area of cross-section A1. The parameter v1 denotes the velocity of a molecule at cross-section A1. The parameter p1 denotes the pressure at cross-section A1. The parameter x2 denotes the horizontal position of the initial cross-section A2. The parameter y2 denotes the vertical position of the initial cross-section A2. The parameter A2 represents the area of cross-section A2. The parameter ρ denotes the density of the fluid. The parameter SSAR, simulation rate, indicates the rate of motion simulation. We observe the motion of the molecules in the fluid stream. In the results table, we display the equations of continuity and Bernoulli's equation, which describes the motion of a molecule with velocity v1 and experiencing pressure p1 at cross-section a1. We calculate the following values: v2, the velocity of the molecule at cross-section a2; p2, the pressure at cross-section A2; v, the velocity of the molecule at height y; p, the pressure of the fluid at height y. We can interrupt the motion simulation. We can hide the vector quantities of the phenomenon. We can hide the results table. We can reset the simulation to its initial environment. We can select various combinations of parameters and study the simulation. Finally, the selection of problems are proposed issues corresponding to the simulation. You can solve the problems and check the correctness of the results with the help of the simulation.